All right, so in this video, we are going to actually start finding some exact trig ratios given angles that are either in degrees or radians that somehow refer to angles on the unit circle. So the first thing I always start by doing is I'm going to write out the trig chart, and I'm going to write out some additional information that always helps me. So the trig chart, I have, let's see, sine, cosine, and tangent. I've got 30 degrees, which is also known as pi over 6, 45 degrees, which is pi over 4, and 60 degrees, which is pi over 3. All right, things I know. 1/2 root 2 over 2, root 3 over 2. Now, one thing you might notice, all the denominators are 2. And if you can count by 1, 2, 3, you can get your numerators. Now, if you can get that first line filled in, reverse it, and that fills in the second line. So root 3 over 2, root 2 over 2 and 1/2. And then this one, there are some tricks to know it, but what it comes down to is I have memorized it. But the basic idea here with tangent is sine divided by cosine. So you can always take 1/2 divided by root 3 over 2, and you'd end up with root 3 over 3 when you rationalize your answer. Root 2 over 2 divided by root 2 over 2 is 1. Root 3 over 2 divided by 1/2 is just root 3. Now, the additional information that I write down, and this is, again, for my memory, and just for me to help, I'm going to put in the ASTC. Now remember, that means in the first quadrant, all of your trig ratios are positive. In quadrant number 2, only sine is positive and it's reciprocal, so that would be cosecant. In quadrant number 3, tangent and its reciprocal cotangent are positive, and in quadrant 4, cosine and its reciprocal secant are positive. So ASTC, however you remember it, this is from many years ago. One of my friends came up with all socks taste crunchy. And that's something that I have remembered from high school because it's completely gross. And yet I remember it. So figure out what works for you. But yeah, I go with the all socks taste crunchy. The other thing I'm going to label are the coordinates for the unit circle along the x and y axes. And I'm going to make sure I don't do anything dopey, like put them in the wrong place. No, I'm good. And the other thing I'm going to label are the radian values at those points. This is, again, things that I've learned that just kind of help my brain deal with what I'm trying to figure out. So this trig chart together with this piece of information is all I need to find a whole bunch of information. So let's start with the first problem. Problem number 1, we're given theta is equal to 600. Now, 600 isn't on the unit circle. And the reference angle that we're going to try and figure out isn't necessarily the coterminal angle, so let's do one thing at a time. Let's start by finding the coterminal angle. So 600 minus 360 equals something that's not going to happen in my head. All right, so that's 240 degrees. That's the coterminal angle. Now, what I want to figure out is how close is 240 to the nearest x-axis. So if I were to think about this in terms of degrees, I know this is 180 degrees. I know this is 270. So 240 is going to be somewhere in here. And basically what I want to do is figure out this little angle right here. So 240 minus 180 would be, let's see, 60 degrees. That's my reference angle, okay? And the other thing I want to make note of is that this is in quadrant 3. All right. Now, part of the reason I care about that is because quadrant 3 only has tangent positive. So I want to be careful about that. So real quick, what did I just do? I took the 600 degrees, found the coterminal angle that's between 0 and 360. That's the first thing I did. Once I knew that coterminal angle, I just did a quick sketch to figure out what quadrant it's in. And then from my quadrant, marked that, I can also figure out what my reference angle is. All right, and this reference angle is what's going to help me figure out then the actual trig values. So 60-degree angle, I know these pieces of information because they're written right here. So let's go ahead and use those. So sine of theta is equal to root 3 over 2. Cosine of theta is 1/2. Tangent of theta is root 3. So those are the initial 3 values that come out of the trig chart. Now let's use those same 3 values, but do their reciprocals to find the cotangent, cosecant, and secant. So cotangent is the reciprocal to tangent. So this would be 1 over root 3. Yes, you need to rationalize, please and thank you. Cosecant is the reciprocal to sine. So that would be 2 over root 3. Again, you need to rationalize, please and thank you. And secant's the reciprocal to cosine. So that just turns into 2. All right. So this on its own is what I just pulled this information from. However, there's one other piece of information I need to use. Remembering that this was in quadrant 3. Quadrant 3, the only thing that's positive here is tangent and its reciprocal cotangent. So out of these 6 trig functions, I need to mark 4 of them as being negative values. So sine's negative, cosine's negative, tangent's positive, cotangent's positive, but cosecant and secant are both negatives. All right, and that's the information I pulled from knowing it's in quadrant 3 and using my ASTC. Okay, so that's the big deal with using that. So that's what happens if you've got something in degrees. Now we're going to do something similar when it's in radians. So 13 pi over 4 is not something that's between, I don't think it is. Nope, no, it's not. Okay, I had to think about that for a second. 13 pi over 4, let's find its coterminal value. So let's see, 13 pi over 4, if I subtract 2 pi. Now on a calculator, I'm just doing 13 over 4 minus 2 and immediately converting that to a fraction. And I'm going to get 5 pi over 4. Now 5 pi over 4 is not my reference angle. So what's going to happen here is I want to graph this to see where it is. So in terms of radians, this is pi. This is 3 pi over 2. This is 0 or 2 pi, and this is pi over 2. You just kind of get used to seeing some of these because you work with the unit circle or you just know those values. Now, 5 pi over 4 is going to be a little bit more than pi, right? Because pi would be 4 over 4, like 1 pi, 4 over 4. So we are down here somewhere, all right? Again, we're in quadrant 3. That won't always happen, of course. Now, the nice part is for your reference angle, it's going to be the easiest thing when you're dealing with radians. Whatever your denominator is, that's going to be your reference angle. So theta here is going to be pi over 4. Okay, and if we think about it, this was pi right here, which is really 4 pi over 4. And to get to 5 pi over 4, if we were to subtract those, right, again, we want to get back to the nearest x-axis, that would be just pi over 4. The easy way to do that, though, would be just to use the same denominator. That will work. All right, so pi over 4 is your 45-degree angle. That's going to be root 2 over 2, root, whoa, hold on a second. These are out of order. So let's see, cosine over here is root 2 over 2. Tangent is 1. All right, cotangent is going to be 1. Cosecant and secant, we're going to flip those sine and cosines, and we're going to rationalize them. So this would turn into 2 root 2 over 2, which is just the same thing as root 2, and that's a root 2 as well. In quadrant number 3, the only thing that's positive would be tangent and cotangent. That's the T for ASTC. So I'm going to make everything else negative. And that way I will have all 6 of my trig values for that given theta value. I'm going to go ahead and close the video here, and I will pop up separate videos for each of the 2 problems. So like the next 2 problems will get their own video, the next 2 and the next 2, to keep the videos relatively short. And this way you can pick and choose which ones you need to or want to watch. Of course, if you have any questions or concerns,